Hi, this is Grover with Blue Collar Codes, Quick and Dirty, a LeetCode series episode for problem 463, which is island perimeter. If you wish to follow along, link to the file is in the GitHub repository. There's a link in the video summary. So I'm going to dive over to the problem real quick so you can get a good visualization of what this problem is. And essentially, you're given a grid or a matrix that has an indeterminate length of internal array here or list, and it's just going to have a sequence of zeros and ones. For each zero, that represents the ocean or water, and each one represents land. And you're trying to calculate the perimeter of the landmass. So for this problem, there's only one large landmass per grid, and you're just calculating the perimeter. Now the difficulty here is just having to calculate based on the ones next to each other need to remove some of the perimeter values, and then you have the outer bounds, meaning the zero index positions for either the external grid, the enclosing list, or the internal list if it's a zero, or if it's at the end of the list. You need to calculate perimeter based on that. So diving over to my problem, or my solution here, for lack of a better way to describe it, I would say mine is an additive approach, in that I am going step by step and adding all the perimeter pieces together and checking for either out of bounds in any direction, as well as then checking for landmass or ocean, and then adding up perimeter that way. So in order to loop through all the values, remember it's a list of lists, so you need to have an external for loop that's going to loop through all of your lists that are internal. And this would be also considered your, say, rows, right? And then you have an internal loop that is going through your column values. And so for this, I just did I and j, and I'm only checking if there is an actual island in that location. Elsewise, it is just skipping past everything. So if it finds a 1 at the current index position or matrix location, then it's going to calculate all these. And for me, it's just easier to visualize what is happening when I write these down, and knowing that I was going to, at least with my approach, have to make multiple checks, then I can just reuse these values that I calculated. And so the first thing I'm doing is just checking to see if the index position, the current position where we're checking, is at any of the outer bounds. So if it's at the 0 column or the full length of the column in J, or if it's at the 0 index position or the full length index of I. So rows and columns. So it's just adding 1 based on if it is just in one of those perimeter locations. And then I'm going and making sure that it is not in one of those perimeter locations. And if it is not in one of those perimeter locations for any of the directions, up, down, left, or right, and it equals 0, then it will add 1. So to go down here, just to give you a little bit of a visualization before I dive into the other answer, that was the top most voted solution in the, on LeetCode. So essentially, if it's one of these positions and it's around water, it will add. But if it's a 1 here, I already added because it's at the 0i index. And so then I'm just checking all of the positions around it. And if it's a 0, I'll add 2 values. So what we first start off with this first row is we're just going to have 3 perimeter value. And then here it would add 1 first on the left check here because it's at 0. And then it would check above it to the right of it and then below it. and it would see, okay, above it is a 0, so it'll add 1. To the right of it is a 1, so it won't do anything. Below it is a 0, so it adds 1. And so that being said, that's my approach to it. It's a bit redundant, so there's a bit of a cost as far as memory and time complexity, simply because it's making these minute calculations and storing them in variables that aren't necessary. And then it's making more comparisons than are necessary as well. As you'll see in this next example, it's definitely more efficient, but it's a bit harder to wrap your head around how the math ends up working out. And that's why we're going to go and iterate through it a bit more. So this next solution is the most upvoted solution again in Python for this problem. And their approach, I would just call it, for lack of a better term, a subtractive approach. Meaning what they're doing is for each one they find, they are adding 4 to the perimeter by default. So they're adding the full amount, assuming that, say, it's all on the edges. And then, only if it is trailing, so only if another one is by it, does it then subtract from it. And here it's only comparing in one direction. It's only comparing above itself, and it's only comparing to the left of itself. And that's why it's a bit unique to wrap your head around. So why does the math work out? So you've got 0, you add 4, and there is nothing above it, there's nothing to the left of it, because it's eliminating that. It's saying if it's an edge case, just skip past it. So after this first row, the perimeter is 4. And then here, it becomes 8. And then at here, it will become 12, but it's then going to subtract 2 for both of these, and then 2 for both of these, because it's only checking above itself and to the left of itself. And then here, it'll add 4 to begin, find something to the left of itself, and then subtract 2. So by the end of this, you're at 4, so you'd be 16, and then it would be minus 2, minus 2, minus 2. So it'd be minus 6. So you'd be at 10. Now does that add up? 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the bottom, it's 10, right? So it does add up. If that were the end of it, it would be 10, because you'd have 3 for the top, 3 for this side, 3 for this side, and 1 for this if there was nothing below it. So after it iterates through all of this, it actually does get the correct value. So let's jump through it and do a debugging round of it to see that in action, say that at least the first 2 rows that I just kind of briefly went over. Hopefully you can follow it. It's a bit difficult just with the cursor. So right here, you can keep watch over here to see what the current value is for our location, and then the rest of the values are up here. So I would keep an eye on the perimeter and how that changes with each step into that I'm doing. So the perimeter just became 4 because the current row's value is 1, so we're actually right here now. Okay. And then it can't check anything there, and it skips. So it skips here because, yes, indeed, R equals 0, but C doesn't equal 0. But if C minus 1 doesn't equal 1, so it just continues on, right? So this was column, it did the column check, it checked at 0, and it didn't find a 1, so it did nothing. So now it is going to be checking column 3 at row 0. It's going to be a 0, so it's going to skip. Now we're going to be back to row 1 now at column 0, right? So R1, C0, so that's right here. It's going to add 4. So see how that value changed to 8. And then since it's at R1, R1, C0, it is going to check this, but it's going to see that it's a 0 above it and not a 1, so it's not going to do any subtraction. And then it's going to iterate to the C1, R1. So you have, it's now at this position, it's going to add 4. But now, since we're in a position where we're not at one of the edges, it's now going to be able to check above it and to the left of it. It's going to see that they're both 1 and subtract 2 for each one and make it current and more accurate. So now we're back to 8, even though we found 3 land masses, right? And so let's iterate again. It's going to find another 1. So we're currently at C2, R1, which is 0, 1, 2 for C, and then R1 is 0, 1. And then it's going to check above it. No, sorry. Yeah, it's going to check above it, and then it's going to check below it. So above it, it's going to skip, but to the left of it, it's going to then subtract. And we can just continue iterating through just to see the full thing. So it's going to find a 0, skip that. Now it's going to go to row 2. So 0, 1, 2, column 0, it's going to find a 0. Now we're going to be at column 1. It just added 4. And now it needs to check above it. It's going to then subtract 2. Nothing to the left of it. And then we'll continue on. It's going to have zeros for the rest, and then we're going to get down to the last row here. So now we're on row 3, column 0. So it's going to find a 1, add 4. There's nothing to the left. It'll skip over. I mean, if there's nothing above it, it's a 0, but it will check it. And then there's nothing to the left of it, so it's going to be skipped. Now, this is the interesting part in that it added it up to 20, right? So we're right here, and then it's going to check above it, and then it's going to check to the left of it, subtract 2 at each one of these locations, and then it literally just came down to the correct answer. And so that was going over this better example of how to solve this problem just because it would be more time and space efficient. Hopefully this was informative. Again, Blue Collar Codes with Grover. Thanks for joining.